Kiran, last week at the Energy Storage Conference, you were talking about virtual transmission lines and virtual dams. What are ye up to?
Kevin, the energy storage resource is a highly effective resource in helping unlock capacity from constrained transmission lines. It's a
Okay.
tool that can be used to increase grid efficiency, accelerate the deployment of new capacity in the appropriate size increments, and provide real savings for utilities and their customers. We call this application the virtual transmission. It's one that has significant potential in the way we think about planning and operating the grid of the future. So the way I come at this issue is from a very practical perspective. Before joining Fluence, I spent about 10 years working on various aspects of transmission planning. And I know that, at least in the US and many markets around the world, we have really old lines that need to be replaced. And so it's not the question of storage replacing all of the transmission projects. We do need significantly new transmission lines to integrate all the renewables. But we do think that at Fluence, one of the questions that we always ask is, what are the specific jobs that energy storage can do within the transmission grid? And we think that energy storage really provides a highly innovative way of solving some of the critical operating challenges that we face in the electric grid by addressing congestion and being able to move power.
And in your presentation last week and in the white paper, it's all about, if you like, kind of replacing some of the physical copper cables with energy storage at both ends, and not, you know, then you have all sorts of black start capabilities, reactive power, power control, a virtual transmission line.
Absolutely. I think the way we at Fluence started this is taking a very application-centric view as a company. You know, Fluence is a Siemens and AES technology and services company. When we started, looking into energy storage, we started with the first commercial lithium-ion project in Indianapolis in 2008. We did the first commercial project in Chile in 2009. All of that was taking a highly application-focused view on the market. Right, so we are looking at specific jobs that energy storage could potentially do on the electric grid. And one of the initial cases that we found was that energy storage was a much more effective resource in providing for the ancillary services in the grid. And the second use case that we found was energy storage could provide this highly flexible peaking capacity in these markets. And slowly in the curve where we are coming to right now is that there are these newer applications that are coming together. The ability to add energy storage to the electric grid, to the transmission and distribution system, which helps it function much better. The ability to add energy storage to run-of-river hydro plants and conventional thermal plants that can actually help these plants actually run much more efficiently. And so those are the newer applications that we are focused on these days.
Okay. Now, before we go to the virtual dam, because that's fascinating as well, from what I know of transmission lines, some of the local controls are in a millisecond, and some of the other controls are within hundreds of milliseconds. Can energy storage technologies today react in the required timeframes?
Absolutely. I think, in fact, that's one of the most fascinating capabilities that energy storage provides for addressing some of the challenges that we have on the transmission system is exactly that speed, that precision, that accuracy in which you need to respond to a signal from the grid, right? In the case of providing, let's say, the grid ancillary services, the energy storage project is responding to specific signals on the frequency side of the house, right? But when it comes to the virtual transmission project, the storage project is actually looking at responding to deviations in frequency or deviations in voltage or any of these type of topics, right? Okay. So, it's sensing if a contingency happens in the grid, and a contingency is a fancy word of saying you lost an element in the grid.
Something's gone wrong.
And so the energy storage project is actually able to sense that and rapidly provide the backup power that you need to keep the grid stable, right? And so that capability that you mentioned, Kevin, in terms of the rapid response, it's in fact one of the key highlights that we're pretty excited about energy storage in this application of providing for a virtual transmission line.
Okay. Now, virtual dams. I think of a dam, I'm thinking something big, physical, lots of water behind it. What's a virtual dam?
So the virtual dam is basically one where you're able to combine battery-based energy storage with a run-of-river hydro project, and provides a way in which you can store the output, electric output from these run-of-river hydro plants, and create virtual storage, right? And we call it the virtual dam application. And this is a relatively new application for energy storage. And what we are finding is that this can offer new revenue streams in the form of energy or capacity that these owners of hydro power plants can sell, as well as providing grid services into the electricity networks where these assets are connected. And so there are some significant advantages for using energy storage in this application. For example, we think of about 1 gigawatt of energy storage, which can be deployed in, let's say, 250 megawatt increments. The size requirement for that is somewhere around the 5 hectares and can be done in about 12 to 18 months, let's say. In contrast, if you think about a reservoir, like physically building a reservoir, I mean, that really takes about, let's say 10 to 100 hectares, and so.
Plus there's a lot more permitting and ecological footprint and.
Exactly. And the time scale is just unbelievable, right? I mean, it takes a significantly long time to actually build a physical reservoir and all the environmental ramifications and all of the socioeconomic concerns that people have and all of those things, that we think that the speed of deployment, the scale in which you can do, all of those are like very key advantages that we can actually really go to market with when it comes to the virtual dam application. And it's one that is applicable around the world, right? I mean, you have run-of-river hydro projects around the world, right?
All over the place,
places in Latin America to places in the US to Europe to Asia. I think you have these type of projects all over the world, and being able to provide a certain degree of firmness in which these run-of-river hydro projects can operate in their power output really creates a lot of value for their local electric system.
And classic energy storage, you can time shift based on the market needs, right? So
absolutely. I mean, I think you can time shift, and you can decouple this issue of, like, the water running through the turbines to generate electricity to actually when the electricity should reach the grid when it's of the maximum use, right? I think that's the decoupling that we are trying to do there, right? Because in most cases, when you have a run-of-river hydro project, as soon as the water runs through the turbine blades, you're generating the electricity, but you're not able to really intelligently match when it is the maximum value for that electricity to be on the grid, which is usually the peak times in the evening times of the grid. And so by able to offer that capability for these run-of-river hydro projects, there is a significant value addition that we're able to do.
And last question, if I may, in terms of your, let's say, a typical virtual dam, what kind of size are we talking about? Hours or kilowatts or gigawatts?
We are actually building this in the scale of megawatts. And so it's in the order of like tens of megawatts.
Mm-hmm.
Honestly, I think the scale in which this application has the potential to grow is in the hundreds of megawatts. In fact, for both of these applications, whether it's a run-of-river hydro virtual dam or transmission connected storage operating as a virtual transmission line, these are like significantly projects that are of high scale, right? So we are talking even in the order of hundreds of megawatts, right? And so in the virtual dam application, we are currently doing projects that are like in the tens of megawatt scale. We expect that will continue to ramp up to get to that hundreds of megawatt scale.
Mm-hmm.
In the virtual transmission line projects, we already see interest and market projects that are in the hundreds of megawatt scale. So that's exactly what we're talking about.
I think it's fascinating. And things like energy storage and whatever, it's when the business people and the new business development people, it's not that they don't care about the technology, but it's the application use case that they can make money out of and use the technology. Most of the innovation came out of people using technology in ways that the guy who invented the technology didn't even think of. Absolutely
the right way. I think as a company, we are exactly in that same way. We call it applied innovation, to be honest with you.
Okay.
Innovation is like you're coming up with a genius idea, right? But then the applied innovation is where you take that concept forward and try to apply it like in 15 different areas, right? We think of it in that way. It's funny because every other parallel in the industry has storage embedded in that network. Data, transportation, food processing, right? Meats, any food industry, You take any other commodity, natural gas has storage. And that's what makes it highly resilient. It's the beauty of electricity that it doesn't have storage in it, right? And that's what creates this interesting dynamic of like, being susceptible, right? Like to like momentary changes, the fluctuations in demand and supply. You can't handle it in electricity. People can handle it in the food industry.
That's a fascinating topic. I hadn't thought of that. The
Yeah.
one network that doesn't have storage built in by default. Now, where do you see energy storage going over the next couple of years?
It's a great question, Kevin. I think that the potential for storage is significant. I mean, if you think back to the time of, let's say semiconductor chips or data storage, we can see a lot of parallel in those type of industries. Initially, these items were reserved to specific parts of our daily life, right? I mean, semiconductor chips in the computer industry and storage in the form of floppy disks, if people still remember that. But what we found is that as a marginal cost and performance of these technologies improve over time, they have become very ubiquitous in every form of our life, right? I mean, today we have refrigerators that have data storage and a large TV screen to show pictures and videos. I mean, who would have imagined that like 5 years ago? And that's the power that technology improvement brings in terms of, improving people's lives and increasing reliability. And so we think that the future is very similar in the case of energy storage. I think we are really looking at the tip of the iceberg in terms of the use cases and applications of storage. I think many additional cases like the virtual dam, virtual transmission lines are being considered in parts of the world. And so I think it'll be very interesting to see how these different applications go through in the next 5 to 10 years as we shape this industry.
No, very true. And as you mentioned, it's about the application. Now, I spend my time looking at the technology, which is the cool bit and all this, but yeah, it's not just a cool technology. What do I do with it? It's the use case. And as you say, that's just, people are figuring out, oh, we can look at it this way. It's fascinating.
Right. Yeah.
Hey, cool. Thank you very much. I wish you well.
Thank you.